Hello everyone! In this video, we will prove using visualizations the derivative of the function 1 over x. In this function, x is the independent variable, and as the value of x increases, the value of function 1 over x decreases. If we plot the values of this function for all values of x, then we get a graph like this. This is a very important function because many important physical quantities like electrostatic potential and gravitational potential behave in this way, and the derivatives of these potentials are the respective fields. So it becomes very important to understand the relationship between the 1 over x function and its derivative. Okay, to understand what happens when 1 is divided by the value of x, let us start by understanding the meaning of division. When you divide some quantity by a number, it means that quantity is divided into that many equal parts, and it gives the value of one of the parts. Let us say we have 8 apples, and it should be divided among 4 people. Then the apples are made into 4 parts of 2 apples each. So the quotient of the division will be what one person gets, which is 2 apples. Using this notion of division that we just saw, we can understand the derivative of 1 over x with an example. In the function, let the value of x be 4, then the value of 1 over x will be 1 over 4, which means that each part will have a value of 1 over 4. Now let us increase the value x by an amount of 0.0001, which means now we will divide 1 into 4.0001 parts, but the same quantity is being divided into more parts. Hence, the value of an individual part will decrease, and the value of the function 1 over x, which will be 1 over 4.0001, will be the value of the new whole part. So to get the derivative, we would need the small difference in value between a single part obtained when x equals 4 and when x equals 4.0001. Let us look at the process which causes the value of the function to change. Since the numerator value is fixed at 1, whatever value for the new part should come by decreasing the existing parts equally and using that value to create the additional part. Otherwise, if we take all the value from a single part or sum of the parts, the whole parts will not have equal values. Since each part is contributing 1/4 of the value, we will have the term 1 by 4. Also, the total value of the additional part will be 0.0001, the part of a whole part value. Then the value of the additional part formed will be 0.0001 times the value 1 by 4. And since this value is the amount of decrease in the function, we would have to put a negative sign. Therefore, the change in value of the function will give minus 1 over 4 squared times 0.0001. This is the change in a single part when the denominator goes from 4 to 4.0001. To generalize this, all we have to do is to take x instead of 4 in the equation and also replace 0.0001 with dx, representing an infinitesimally small change in independent variable x. When we break this down, we can see that for any value of x, the change in the function 1 over x for a small change in x will be minus 1 by x squared times dx, where 1 over x represents the contribution of each of the x parts, dx times 1 over x represents the total value of the additional dx part, and the minus sign represents a decrease in the function's value. Finally, taking the ratio of the functional change to the change in the independent variable will give the derivative of the function 1 over x as minus 1 over x squared. If you liked our intuitive and visual proof of the derivative of the function 1 over x, then smash that like button, share it with your friends, and subscribe for more amazing math and physics content.